guys like getting the weekly emails? Do you like that idea? Did you get the email?
I did this time.
Okay. Do you like them or something you guys don't want? Or
Which email is this?
it's the announcement?
It was okay. Doesn't hurt. A reminder. Might be useful as the course goes along.
Yep.
Yeah, just send them.
Like the cat picture?
I never saw the cat picture.
They're not my cats. Or my foster cats or my step cats. My foster cats. What is a step cat? I gotta get in a plane for 11 hours. I'm not very excited about that. So,
Where are you going?
Washington, D.C. Or Washington, as my dad says. I say Washington. Yeah, it's from I got a grant, and it's every other year there's a meeting, and so I'm going for a meeting. But hey, all right, well, I guess it's time to start. Anybody have any questions about anything before we start? Okay, so that's where we left off last class, and this is going to be a good class for you guys because we're going to do some calculations today, finally. We can do math, but we're going to start off talking about naming. So before we get to naming stuff, let's talk about just right here. So if you remember in the first chapter, we talked about pure substances. Certain pure substances, you can take mixtures and break them down into pure substances, and they can be elements and compounds. And elements, they can either be atomic. I assume a metal then is also considered atomic, or they can be molecular. And then compounds can either be molecular or ionic. So ionic compounds are one atom gives electrons to another atom or groups of atoms. That is also bonding between metals and nonmetals. So nonmetals bond to form molecules, and all the other nonmetals that are, when they bond with themselves, they form molecules with the exception of noble gases. So let me pull up a periodic table real fast.
Can you say that one more time?
Yeah, that's what I'm going to do.
Okay.
So elements. All the metals, they form metallic bonds. The noble gases, they just have plain old atoms. The nonmetals, they bond with themselves in molecular bonds. So what's a molecule? A molecule is a stable group of atoms. So think of a stable couple, right? What's a stable couple like? They're always together, they're holding hands, they're happy. What's an unstable couple like? They get together, fight, and then they fall apart. Yeah. So what's an unstable molecule? Literally unstable molecules are explosive. They explode. They fly apart. So same thing with couples. People and molecules are very similar. Stable couples stay together. Stable molecules stay together. Unstable couples and molecules blow up and separate. So stable molecules, so nonmetals, with the exception of the noble gases, elementally will form bonds with themselves. Most of them are diatomic. Well, nitrogen, oxygen, fluorine, and the halogens are diatomic. Carbon makes big molecules, diamonds, graphite, these types of things. Phosphorus has two main forms, and same with sulfur. They're not diatomic, they kind of form clumps together. And then the metals, they tend to just form just plain old metallic bonds. They hang out together and they have electrons float between them. The semiconductors, the metalloids, they tend to form molecular structures, kind of like carbon does, like a diamond, for instance. A diamond is one molecule. Okay, and so let me go back to this. So noble gases are atomic elements. The other nonmetals are molecular. Nonmetals with nonmetals form molecules, covalent molecules. Metals and nonmetals form ionic bonds. So one transfers electrons to the other. And here's an example of two. So here's propane. So like if you're grilling something with a propane grill, this is the fuel. It's a stable group of molecules. So 8 hydrogens and 3 carbons all hanging out together. And they're stable, they're not unstable, they don't fly apart. And here's sodium chloride salt. You have the big chloride anions and the small sodium cations. So just real briefly with this. So what is this that we're looking at here? This would be, the atoms look like they're the same. This would be, it's a pure substance. It's an element. It's a diatomic, 2 atoms, diatomic elements. And let's categorize each of these as atomic elements, molecular compound, or ionic compound. So if I'm highlighting in red atomic element, xenon here is a noble gas, it's an atomic element. In yellow here, ionic compound, nickel chloride, so metal, non-metal, this is an ionic compound. Molecular elements here in pink, bromine is a molecular element. It's not a noble gas, it's a non-metal. Here in blue, nitrogen dioxide, this is a molecular compound. And sodium nitrate, this is a metal and non-metals, this is an ionic compound. So that's just real brief. How are we doing? Anybody have any questions for this? So next thing though, we're going to talk about naming things. I always think of Romeo and Juliet, right? What's in a name? Would a rose smell as sweet as it were called by a different name? Would calcium bromide be as amazing if it was called something else? Okay, so let's start off with ionic compounds. They're the easiest. So ionic compounds, and these are when you have the cation. Basically, it's the alkalis and the alkyl-inerts. Alkalis are +1, alkyl-inerts are +2. So when you have a compound, you have the name of the metal, then plus the base name of the nonmetal, plus I and DE. So calcium and bromine, these two together. You say calcium because that's the name of the metal. It does not change its identity at all. And then bromine, you short it to brom plus IDE, bromide. So this is calcium bromide. And bromine is a halogen. It has a -1 ion. Calcium's a +2, so the charges are even. So you'll do this. There's a lab next week where we go over nomenclature in lab. So you'll do this quite a bit.
Is that this class or the actual lab?
The actual lab.
So
Don't do a little bit of both.
We try to align it, right? We're trying our best to align the classes so that they support each other. Okay. So what about metals with more than one charge? You say the name of the metal, just like before. Then when you speak it, you say the charge, as in 1, 2, 3, 4, 5, 6, 7. And then the same thing, base of the anion plus IDE. And when you write it, you write the charge in parentheses and in Roman numerals. So this one here, lead can be +2 or +4. In this case, so chlorine is -1. This forces lead to be +4. This is lead 4 chloride. And the way Roman numerals work, so you really typically don't see charges past 7. Even that's rare. You usually see smaller, but Roman numerals, I is 1, V is 5, X is 10, L is 50, C is 100, M is 1,000. For chemistry class, you're probably never going to go above 7. But the way Roman numerals work is if you have something before the letter, it's subtracted. If it's after the letter, it's adding it. So 1 is I, 2 is I, 3 is I, 4 is 1 less than 5, it's IV. 5 is V, 6 is VI, so it's 5 plus 1. 7 is VII, so 5 plus 2. 8 is 5 plus 3, VIII. 9 is 1 less than 10, IX. 10 is X. So, you'll see these in buildings, like if you see like MMXIII, that's 2008. That means a building was built in 2008. So, but, okay, but these here, they're pretty easy, but if you have to memorize something like that, if say you forget this in a test, I'll tell it to you. So if you tell me what's 3 in Roman numerals, I'll tell you what it is in Roman numerals. Right? I'm not going to be wearing our togas and our laurel leaves coming to class. Okay, some more things you don't have to memorize. So here is a chart showing metals with different charges. And the old way of doing this, saying ferrous and ferric, for instance, for iron, no one ever does this anymore. So maybe Peter Fisher, if you have Dr. Fisher for lab, he might say that. He's pretty old. But me and Dr. Tibbetts, we won't say that at all. No one really ever uses it anymore. And to illustrate to you why it's tough being a chemist, is because the humor is absolutely terrible. Chemistry jokes are god-awful terrible. And I'll give you an example of one. Can anyone guess what I'm drawing here? No one wants to guess? It's a Ferris wheel. Yeah.
That was pretty bad.
For dads, isn't it?
That's a dad
Chemistry,
joke.
my dad's a chemist, so.
That was horrible.
Oh, yeah.
Go home.
Go home? I wish I could. I gotta go to DC instead. I'm gonna go on a plane. And I wish I could go home. That's what I'm doing after class. All right, so the next thing we'll talk about are common polyatomic ions. So if you are in a monogamous relationship, how many people are you in a relationship with? One. If you are a polygamist, how many people are you in a relationship with? Yeah, 2 or more. Yeah, more than 1, 2 or more. So a monatomic ion, how many atoms are in a monatomic ion? 1. How many atoms are in a polyatomic ion?
Whatever they fancy.
Yep. Yes, so polyatomic ion, many atom ions. It can be 2, so hydroxide is just 2. But you can have acetate. This is a 7-atom molecule with a charge on it. So you can have several. This is something you do not have to memorize. This will be provided to you. So my school of thought is on some of this stuff is you as a student, about your experience. I don't want you to have to memorize. I know that chemistry has a lot of memorization, and I remember it, but I'm a chemist. I've been doing this for a very long time, plus my childhood. So, for you coming in doing this, you're not going to know it it would take you some time. You'd have to do flashcards and acetate, and then memorize the number of atoms in acetate, for instance. So I'm not going to make you do that. All this information will be provided to you. You'll get lots and lots of given information. You are going to have to know how to use it, though. So during tests, you can also ask. So the morning class, people asked if I have a hard time remember that milli is 1,000. Do you have to remember that? I'm like, well, if I don't give it to you, you can ask that during a test, and I'll tell you. The questions I don't answer are strategy questions. So it's like, how do you solve this problem? Well, I'm not going to tell you that. Or do I use this or that? I'm like, well, that's not fair game. What's the symbol for lead? I tell you PB, and it's right here in the periodic table. I would do that. But but not, did you balance the charges? I wouldn't do that. Okay, but the other caveat with that is if you go on and you take tests like the MCAT or the GRE in chemistry, so other standardized tests, you will have to know this stuff. But I'd rather you focus on learning the material than have to worry about memorizing the stuff and on top of that learning the material. Besides, I'm sure besides the lab, you have other classes too. So I think most of you are full-time students, right? Or am I mistaken? Got other stuff going on. Not that chemistry is not important and all right, awesome, but I get it. Okay, so moving on, let's look at molecules, naming nonmetals. So the way you name nonmetal molecules, you have the prefix, the name of the first element, prefix, the base of the second element plus IDE. Now, if the first element is 1, you drop the mono. So here are the prefixes here. Mono is 1, di is 2, tri is 3, tetra 4, penta 5, hexa 6, hepta 7, octa 8, nona 9, deca 10. And mono is dropped for the first element. So to give you a couple examples, so I know we'll have an example next, but you're probably familiar with these molecules, CO and CO2. So you name you say the full name of the first element, carbon. You don't say monocarbon, you say carbon. But the second one, you have to use the prefix. This is carbon monoxide. And this is carbon dioxide for the two. So, and another thing about naming things, there are some common names. So many molecules, we have common names. So NH3, we don't call it nitrogen trihydride, we call it ammonia. Water, we don't call dihydrogen monoxide unless you're a crazy chemist, right? So that has its own specific name. But there are some common names that you don't even realize are common names. So acetate is actually a common name. The proper name would be ethanoate. So, because 2 carbons is F like ethanol. So, but acetic acid should be ethanoic acid, but we call it acetate. The other thing that's common, common like chemistry colloquial, if there is such a thing, the word bi. Bi can mean in the naming context, bi means an extra hydrogen. So soda, for instance, is washing soda is sodium carbonate, NaCO3. Bicarbonate of soda, or sodium bicarbonate, is NaHCO3. So that bi gives an H. It's bicarbonate of soda. So it's NaHCO3. So baking soda, bicarbonated soda. Probably no one calls it bicarbonate of soda unless you're like a Victorian era, like pharmacist or something. So we call it sodium bicarbonate or baking soda. So like the hydrogen sulfate, it's bisulfate. And there's other names that you think would also be the proper name. Vitamin C. Vitamin C's name is ascorbic acid. That's not a scientific name. Ascorbic acid is anti-scurvy acid. If you eat this acid, you won't get scurvy. That's what vitamin C is. So anti-scurvy acid. I don't know what the real name, like the proper scientific name of ascorbic acid. But it's amazing how many names like that we have. Okay, but let's name some of these proper compounds. So name each of these. I guess so the first one, I like blue better. So the first one, you write the name, nitrogen, and then 3 iodides, triiodide. So nitrogen, triiodide. And when you type these out though, they wreak havoc on your spell checker. So just so you know, if you ever write something on a Word document you're going to see a lot of squiggly red lines whenever you write compounds, because they're not in the memory. Next one here, you spell out the first element, phosphorus, and then 5 is pentachloride. So, how would you like that for a spelling bee word? And then these are all mono. A and B are mono. C, though, has 4. You have to include the prefix for this one. You drop the mono for 1, but this is tetraphosphorus. Tetraphosphorus. Oops, deca. Yeah, decasulfide. Decasulfide.
It's fun.
So tetra is 4, deca is 10. Tetraphosphorus decasulfide. So questions with this? What?
That was a mouthful.
What's so hard about tetraphosphorus decasulfide?
Yeah.
Okay. Next thing, binary acids. So when you have a binary acid like HCl, and you can see that I do this colloquially as well. I call it HCl. Many of these also have common names. Does anybody know the common name for HCl? Muriatic acid. So, but
Is it HCl hydrochloric?
it is.
Yeah.
Yeah, but I mean the common name.
Is it common name?
Yeah, muriatic acid.
I thought it was just always hydrochloric acid.
But
Used to be.
it's also, I mean, we don't use, like, that's kind of also old thing. Yeah, I mean, people don't say it. Like, it sounds like something like Sherlock Holmes would say or something. Like muriatic acid. Okay, so the way you name just binary, so 2 atoms, acid, and notice that there's always an H in there. You say hydro, base name of the nonmetal, ic, acid. So HF, hydrofluoric acid. HCl, hydrochloric acid. HBr, hydrobromic acid. HI, hydroiodic acid. So, like that. Now, the next thing is oxyacids. Oxyacids, what is an oxyacid? An acid that has oxygen in it. So, oxyanions ending with ate, ATE. For that, you say the base name of the oxyanion plus ic plus acid. Oxyanions ending with ite, the oxyanion plus us, acid. So SO4 is sulfate. H2SO4 is sulfuric acid. HSO3 is sulfite. H2SO3 is sulfurous acid. And you will get the name, if you have to name something like this, you'll be given the names of the polyatomic anion as well. So you're not gonna be left high and dry on this one. You have to memorize it all. The other thing that, just to confuse you even more, there is no convention for what is an ate and what is an ite. So SO4 is sulfate, SO3 is sulfite, and NO3 is nitrate, NO2 is nitrite. So there is no consistent rule. And to even further confuse you, which is not in the book doesn't cover this, but I wanted to show you either way. So ClO3, this is chlorate. If you have an extra oxygen, it's perchlorate. So this is chlorate, this is perchlorate. So this is chloric acid, and this is perchloric acid. So this is ClO2 is chlorite, this is chlorous acid, and one less oxygen than the ite is hypoite. This is ClO is hypochlorite, and the acid is hypochlorous acid. So remember bleach. Bleach is NaClO, like the stuff you put in your laundry. I use it for a lot of things. I use it to clean a lot of things. Bleach is sodium hypochlorite.
We need to hear that a few times.
The names are important, but they're also, you'll be given this flow chart and any of the names of the anions, so you'll be able to figure it out by using logic. As long as you can apply your logic, you're good. Okay, so here's the overview. So ionic compounds, metals and nonmetals. With only one ion, you say the name of the metal plus the root of the anion plus IBE. So CaI2, so calcium iodide. So calcium and iodine, you iodide, and then you put IBE, so iodide, calcium iodide. If you have a metal that has more than one charge, you include the number in Roman numerals. So iron 3 chloride, so Cl minus is a -1. It forces the iron to be +3. Then that means you have iron 3, which is III in Roman numerals, iron 3 chloride. Then for molecular compounds, prefix, name of the first element, unless it's 1, you drop the mono if it's just 1. But then prefix plus the name of the first element, prefix plus the base name of the second element plus IDE. So P2O5 is diphosphorus pentaoxide. And acids here, which we just covered, binary acids, just hydrogen and another element. You say hydro, base of the nonmetal, plus ic, plus acid, HCl, hydrochloric acid. Oxyacids, for 8, you put the name of the oxyanion plus ic plus acid. So phosphate is phosphoric acid. Ite, it's us acid. So sulfite is sulfurous acid. So, questions with this? Yeah, chemistry, actually, there's a lot of rules, but it actually does make a lot of sense. If you do it for a while, you'll start to see the connections. But I know as you as a student going through that, you're like, holy freight train. Okay. Huh?
As long as you know that.
Yeah, no, I know. No, in Chemistry 161, so this is actually one of the most hated classes. So, and because maybe you've noticed, every single class you come to, you get a new mental model. So the teaching term, the mental model, you have to memorize. You have to learn so many mental models in Chemistry 161. It's just not, it's crazy. The nice thing about Chemistry 162 is that the pass rate for that is higher because 161 is just such a freight train of a class. So I took you guys, Chinese class. So, there's a lot of mental models for Mandarin Chinese, right? You have the calligraphy, the logographic alphabet, you have the common, you have the ancient, then you have the pinyin, then you have the tones, right? There's all these things. Those are all mental models you have to master. What about chemistry? Well, this class. Well, we're starting off, now you have naming. It's a whole new mental model that we covered in 20 minutes, right? And then we're going to start covering stoichiometry, which is a big mental model. And then after that, we're going to go gas laws, new mental model. After that, thermo, new mental model. After that, Lewis structures, new mental model. It's you come to class, you learn a new mental model, right? So it's tough. So no, I get it. Okay, but speaking of new mental models, here's our next mental model. The formula mass and the mole concept. We've already talked about the mole, and we're going to start by calculating the formula mass. So the formula mass is the number of atoms in the first element times the atomic mass plus the number of elements in the number of atoms in the second element times the atomic mass, and so on. So, and the atomic mass, they are these numbers on the bottom of the periodic table. So let's calculate the formula mass of glucose. So glucose is C6H12O6. So what does this mean? This means that this subscript means that there are 6 carbon atoms, there are 12 hydrogen atoms, and there are 6 oxygen atoms. So when we want to calculate the formula mass for glucose, so it's 6 times the molecular, or the atomic mass of carbon, plus 12 times the atomic mass of hydrogen, plus 6 times the, it's not, my O is the same as my 0, OX for oxygen. And I'm getting those numbers from here, like so. So it's 6 times 12.01 plus 12 times 1.008 plus 6 times 16.00. And where are these numbers coming from? They're coming from the periodic table. Oh, that's, there we go. They're coming from the periodic table, the bottom part of the periodic table. And if you throw this in your calculator, this is 180, I think it's 0.16. I know it's 180. 180.16, yeah. I have that one memorized, the molecular mass of glucose. I don't have them all memorized, but I know glucose is 180, I know sucrose is 342, carbon dioxide is 44, oxygen or water is 18, stuff like that. But, okay. So how many questions? All right. Now I'm going to do a problem, and then you're going to get to do a problem. So you'll finally get to do some math in class. It'll be you and not me. Okay, so an aspirin tablet contains 325 milligrams of acetylsalicylic acid. Can you see that 3 times fast? Acetylsalicylic acid. So 325 milligrams of acetylsalicylic acid. How many acetylsalicylic acid molecules does it contain? So the way you do this one, this is dimensional analysis. So I had a lot of students ask questions about this last class, so I'm going to go ahead and write this out. So a colloquial example is seconds in a year. So 1 year, 365 days in a year, 24 hours in a day, 60 minutes in an hour times 60 seconds in a minute. So that's how you calculate the number of seconds in a year, right? And the units all cancel. So same thing here. So 325 milligrams of aspirin. I'm just saying A, I don't want to write out aspirin or acetylsalicylic acid. So 325 milligrams. And I would probably skip this step, but I'll put it in there. So meaning I would write, instead of 325 milligrams, I put 0.325 grams. But you can divide by 1,000. And the next thing is we have to figure out, so moles of aspirin. This is where we need the atomic mass, I'm sorry, the molecular mass of aspirin. And so it's 9 times 12.01 for carbon, plus 8 times 1.008, plus 4 times 16 for oxygen. And this equals 180.15. So it's almost exactly the same as glucose. But that's just by chance. That's not how typically it is. So 180.15 grams of aspirin is a mole of aspirin. And then Avogadro's number is 6.02 times 10 to the 23rd. So aspirin molecules to mole of aspirin. And you throw that in your handy dandy calculator, and you get 1.09 times 10 to the 21 aspirin molecules. And I'll go ahead and put that in my free cell phone. so you can see what I'm putting in there. Now it wants to show me that. Okay. Where is it? Oh. Water bottle's in the way.
It was really small.
Yeah, I know, I'm assuming. What, you can't read that? But I don't want to cover up the other thing. So if you see what I've put in there, so I went ahead and divided out the step, the 325 divided by 1,000, I just put 0.325. And then so these are multiplication, these are division. So 0.325 divided by 180 times 6.02 times 10 to the 23rd. And on this free calculator, it has this EXP exponent key. Many of the calculators, they typically have this E button. So you can use that for the times 10 to the 23rd. That using the E button will make your life much easier. So, okay. So recap with this. Man, this thing is slow. Come on. Come on, internet.
You gotta back it up a couple times.
No, it's
Yeah,
just,
the internet's been really slow today, just in general.
yeah. It's faster in the morning.
More classes.
Okay. All right, so we're doing dimensional analysis here. So, and to solve this problem, how many molecules of aspirin are in 325 milligrams of an aspirin tab, acetylsalicylic acid? So we start at 325 milligrams, convert to grams, figure out the molecular weight of aspirin. So has 9 carbons, 8 hydrogens, 4 oxygens, and so then multiply by atomic masses of each of those elements times the number of elements, and we get 180 grams per mole. So 180 grams per mole, and then Avogadro's number for the mole here. And notice here, milligrams cancel, grams cancel, moles cancel, and then we get the molecules like that. So, anybody have any questions with this? All right, now your turn. So, I tend not to use aspirin. I tend to prefer ibuprofen. How many ibuprofen molecules? Ibuprofen is 13 carbons, 18 hydrogens, 2 oxygens, and a 200 milligram tablet.
Why do you use ibuprofen instead of?
Aspirin?
Yeah.
It's a stronger COX-2 inhibitor. So, do you know what COX-2 is? So, aspirin and ibuprofen, the way that they work is they work on. Do you really want to know the answer?
Yeah.
Okay.
Well,
So with pharmacy,
I took a lot of one or the other, and I go back and forth because they both get absorbed in different parts of the body, right? And you want to.
no, both stomach.
What?
Both stomach. They have the same similar thing. They're ibuprofen is a stronger COX-2 inhibitor. What's a COX-2 inhibitor? Say I sprain my elbow. It sends pain sensors, specifically COX-2 pain sensors to the brain. I mean, it hurts, but then you have the COX-2 signal. COX-2 signal says it's injured, it needs to be protected, so then it swells up. So swelling up is a way to protect an injury. What aspirin and ibuprofen work, and they do the Jedi mind trick, like, there is no injury. There is no need to swell up, and then it blocks the COX-2, and then it's anti-inflammatory. It doesn't engage in that chemical pathway to swell, or swells less. So, aspirin, ibuprofen, sodium naproxen, Celebrex, Vioxx, they all work off of COX-2. Aspirin and ibuprofen are also COX-1 inhibitors, which affect your stomach and kidneys. It shuts them down.
Mhm.
So you pee less if you take aspirin or ibuprofen.
So for ibuprofen, is it you take the atomic mass of carbon and multiply 13
Yeah.
times, and then
Yes.
to H 18 times and O2 twice?
Yes.
That
I'll,
gives
I'll
you-
write that. This next thing. Yeah.
Do we have to do that, or can you just give it?
This one?
You really want to do? Okay, it's 206. So it's carbon is 13 times 12 plus 18 times 1 plus 2 times 16 for oxygen.
Okay. And it's just 206.
If you really, if you really,
So you start off with
So.
how much you have.
all right, you guys are, let's see, you guys are already working in groups. That's cool. I was gonna see if is anyone stuck? Does anyone have no idea what to do whatsoever? You know what to do. Okay, start working. Do you want me to keep this up here, or do you want me to zoom in on here? Like,
Either one.
Yeah, C13, C13.
I might zoom in here. Okay.
Times, you want to convert kilograms to grams, right?
So it's one.
So 1 gram is equal to 1,000 milligrams.
That's okay. Don't. Okay.
Next, you do, yes, but doing it this way makes sure that your units are consistent.
So
So
once
this
you
is
make
like-
it 0.2, it's now 0.2 grams.
Yes.
You drop the milligrams.
Right. And
Okay.
this is
So now 0.2. Okay.
Oh, you already have the answer.
yeah. So
I'm gonna come next to you.
So
Yes.
0.2 is
Just
Okay. So you see,
so then,
so back here,
I think I'm
yeah, 320 milligrams. This is converted to milligrams and grams. Yeah.
What is this? What do you
Yeah.
want?
And you understand this up here? Okay, so it's the same step as up here for the formula.
So now,
You
we
need
go
more
from,
steps.
So glucose,
now we go from
carbons,
grams to
12 hydrogens.
moles.
So
So
here,
one
on this step,
mole
there's 9 carbons,
is
hydrogens,
6.02. So,
and in this step, 13 carbons, 18
We would have
hydrogens,
the
12.
way to the muscles all.
So this one here, you would have 200
6.22 times 10
milligrams ibuprofen.
Oh, yeah,
Two
oh,
times.
the bottles and all
Is
that.
it always 1 mole is always this amount?
Yes, this is the
Okay.
conversion, so this will always be the same.
Gram
Mm.
ibuprofen.
And the times,
1,000 milligrams.
your atomic mass of this, which is 206.
When you find all these things?
You find the atomic mass by taking the atomic mass of
Last
carbon
step is
multiplying
other
by the
numbers.
atomic mass of hydrogen by 8, then the atomic mass of oxygen
Smaller
times 2.
So when you're talking, you can just do that.
Yeah,
So
cancel.
that exponent will be times
Not exponent, because it's just multiplying.
Not very
The calculator?
Because
The top numbers,
by
So you
multiplying
want
the
to
bottom
like
numbers
this,
to
you're
the
gonna
high.
calculate it and multiply it, like, you know.
Just times 13.
Yeah,
So you
divided
take-
by 1,000.
So you take your carbon,
Because
12,
in my brain, I need it.
right, 12, then times 13.
So how do you?
So if you,
Okay, let's see if
carbon
I- it's easier if you, so doing
That's
this,
how
you
many?
do 200
the top number, that's how many.
times 6.02 times
And
10
This is its atomic mass.
And do the every table show you this?
then divided
Try to
by
get one.
1,000 divided by
So,
So 12 oh,
yeah, I
12,
mean,
oh,
we
one,
could do
one
it here,
times
so it would be
13.
like 12.01
yes.
times 13 plus whatever hydrogen is.
Can you put this in the calculator?
Okay.
And now we get your atomic mass, but he said it's
206.
206 grams.
Because I didn't do grams.
Yeah, per grams
For one mole.
per
Yep, okay.
grams moles to.
I think you go grams.
Oh, wait,
So one mole. So this needs to be here and this needs to be here. Because one mole is equal to this.
You're solid only that's four?
This.
Okay.
You still want the mole though. You want the 206 underneath.
So,
Yeah, you got it.
206, yeah.
so it's, one mole.
How are you doing? Are you following?
6 grams of that.
Yeah, that's right.
Of this of ibuprofen.
Yeah.
So one mole is 206 grams of ibuprofen.
Okay, yeah, that's the right setup.
Multiply
Oh, except for what's that number?
You didn't have to do this.
So 10 or
Yeah,
okay.
That should be 206.
Oh.
You can look right here.
Well, so what comes first?
This,
200 milligrams.
so you get one of these, you do this.
What's the exact calculator?
So you do this.
You didn't?
200 times fraction 1 over 1,000.
Oh, because you're using E. You're using that's Euler's number. No.
Oh, is that what that is?
I think that's
Cool, I have that same calculator.
No, it's not E. Yes.
5.845, 85?
Yeah.
5.5?
But we're going
Yeah.
just one
E
six,
is one of those numbers. It's close to 3.
Yeah.
I just,
so it should be six.
yeah, I think I multiplied everything.
It was like
Okay.
Yes.
That's why I got such a big number.
Yeah.
I just,
Okay.
I just can hear it.
It probably makes a difference. Molecules, yeah, so molecules.
Just everybody scratch out. See what it does.
Oh, it's 23rd.
But he has 2 cities.
But remember,
So it would be 5.
you don't take any of the conclusions into account for
What do you put in your calculator?
digits, right? That's what my lab teacher said.
Yeah.
On this first one. So it should be 6 times 10 to the
Well, it's not up there, so I'm gonna go with 5.
I thought it was B, but.
Well, it would
10 to the
still be
20.
10 to the 20.
Oh, yeah.
That's the same thing, but it should be 6,
Will you
right?
screenshot this and send it to me? Mama.
You didn't divide by 1,000.
It's not too bad. It's
For
That's why you're getting 23 and not 20.
I forgot my dad did that.
Either way, it seems like you did it right, but you need to divide by 1,000.
It's gonna rain.
yeah.
That's
That's
not
100.
Divided
Divided by 206. 6 times.
That's not what we were talking about, I was talking about the weather. I was like, you're not responding about the
I know, I
weather.
wanted to mention that.
Give me that down.
Oh, yeah.
That down.
I
Turn them off.
Yeah.
2.
0.2. Yeah. Yeah.
Cheers.
That's a good.
Yeah.
Let's get it so you can put the number in the calendar. It's important to you.
Nah.
Wednesday.
Times
MailChimp.
6.32.
Hi, MailChimp.
Well, okay. Yeah. But then you gotta multiply it by 10 over
Okay,
10.
I sent it to you. Yeah, it's not too bad, right?
No, it's easier to break it up. That's why I cannot go job off. Yeah. I have to sell you.
Oh, okay, yeah. That's
Months.
like a main
Or this.
What's study?
Share.
Shred is learned.
Same thing.
Study is study.
So
Share.
you see how to do that?
Share.
Yeah, you did it right the first time. You said divide by 1,000. how you guys doing over here?
5.8 times 10 to the 20?
Is this simplified Chinese? No. Traditional, of course.
Oh, you're talking about Chinese.
No, I don't. I'm telling you.
Okay. So, answer is 5.8 times 10 to the 20. So, but you probably could have gotten this without doing any calculations, though.
Fushi is really.
So, when you take tests, see if you can discount answers. So when you're taking tests, see if you can discount answers. 206, that's the molecular mass, and also that's too small. 200 molecules, that's a really small amount. And this 9.7 times 10 to the minus 4. So when you deal with chemistry, what's that?
It's less than 1.
Yeah. You deal with something called discrete mathematics, where you have to deal with whole numbers of populations. So having a number like this does not work for a molecule. You can't have a fraction of a molecule. You can have a fraction of a mole, but you can't have a fraction of a molecule. You can have a half dozen people, but you can't have a half of a person, right? So,
I mean, you could
You
have,
can.
but
yeah, well, let's look at a different way. So I was an intern for Bath and Body Works and Victoria's Secret.
No.
Interesting.
Wait, what?
Yeah.
Oh no, like chemists.
Intimate brands, yeah. Intimate Brands is Bath and Body Works and Victoria's Secret, and I was doing process design for them. And the way that you make a candle, I was looking at making candles.
I watched Fight Club. I know how to do this.
Making candles? Or soap? That's soap.
Oh yeah, I guess it's not.
Yeah. The book is better than the movie.
So I've heard.
The Brad Pitt is better than all of it.
Not my thing.
Not gonna lie.
Okay, but the way you make a candle, you have a mold, you pour wax into the mold, and then when it cools, it shrinks. You pour it again, and then you slap the label on top. So if you ever have a pillar candle, if you peel back the label, you can see where they did the second pour. But so you have the mold, you pour it, it cools, you pour it again, you put the label on top, and you take the candle out of the mold, you drill a hole through it, and you add the wick, and then you package it and you move it down the line, you put it into boxes. So I was doing calculations to see how much time it takes to do each step. Remember, at one point in time, I found out I needed 2.3 people at this station, which means I need 3 people, right? You can't have a fraction of a person. You can only deal with whole people. Just like with chemistry, when you have molecules, you can only have a whole molecule or a whole atom. You can't have fractions of it. But you can have fractions of moles, because you can have a half a dozen, right? You can have a half dozen, so you can have a half a mole. That's fine. Fractions of moles is totally fine.
Fractions of moles.
Wouldn't it be 6 times 10 to the 20 if you did a significant figure rule?
Oh, 200 milligrams. I guess I see your point, saying it's only 1 sig fig.
Our lab teacher is pretty
Yeah.
strict about that.
Is it Jeff or is it Peter?
Jeff, is it?
Okay, yeah.
It would have been 6 though, right?
I mean, really, it should be 3, but I guess I don't. I mean,
It should be 3.
It's less.
it's 200, but I mean,
But
I'm also
hundreds
I
of
see your point. Yeah, but this is also the purpose of this one is really to get your calculations down.
It should have been 6.
Yeah, I see your point, and yeah, it should be by 1 sig fig would be 6 by times 10 to 20.
But isn't it more accurate to do 2 sig figs?
Well, it depends on what the measurement is. When I made this problem, I didn't make it to with sig figs in mind, to be honest with you.
Would you? I was gonna say, would you have marked it wrong? If one
No,
was put 6
no,
and the other one put 5.
no, because this is would be a multiple choice test, and this is clearly the best answer.
We only do multiple choice.
Yes, actually,
Oh,
the test.
nice.
Yeah.
And there's always gonna be a dummy one, so it's really like best out of 3. It's great. I'm loving these odds.
Well, I mean, chance is still. When you can by the score of the test, you can tell how well the student understands. But they actually can be very hard. But for me, myself, later on, many of you are pre-professional. A lot of people are pre-professional, especially chemistry. You want to go on to be pharmacists, to be doctors, or something like that, and you take other tests too, like the MCATs and whatnot. So, and those are multiple choice.
Yay.
So GRE is multiple choice. So, but I'm trying to also get you to understand test-taking skills, and that's what I'm talking about right now, is that these two you can already eliminate. So these two answers, this one is physically impossible, this one's way too small, and at 200 milligrams, so 200 milligrams there, and ibuprofen about 200 grams per mole.
The 10 to the 20 and the 10 to the 23 is to make sure we didn't mess up the grams to
Yeah.
the milligrams to grams thing.
I didn't intend it that way, but it does turn out to be that way.
I do that a lot.
Yeah.
So,
Yeah, but
like this morning.
Yeah.
I was just thinking.
but at 0.2 grams, you know it's not going to be at a proper mole. So 200 grams of ibuprofen would be a proper mole, but it's 0.2, so it brings it down by quite a bit. So really, of these answers, you could discount it, so maybe A or B, and B is probably more likely, at least by the amount that you have. Especially if you do these problems over and over again, you will kind of get a knack for that. Like, oh, okay, so 200 milligrams, 200 grams ish is going to be about a mole, and that's about a mole. We have less than a mole, so this is the one that's closer. So, okay. Questions so far? All right. Now, how many atoms? So we have this 5.8 times 10 to the 20 molecules. How many atoms are in that molecule? And I'll go ahead and, so it's C13H18O2. So how many atoms are in this molecule? 18 plus 2 is 20 plus 13 is 33. 33 atoms, and then 33 atoms. So we figured out the number of molecules, 5.8 times 10 to the 20th times 33 atoms per molecule. So, yeah, so it's 5.8 times 10 to the 20 times 33. So 6 times 30 is 180. So it'd be 1.8 times 10 to the 22nd, or 1 point. Question?
Where'd you get the 33 atoms from? Did you add them together?
Yeah.
Yeah,
You did, you
13,
added them?
13 carbon, 18 hydrogen, 2 oxygen. So 18 plus 2 is 20, plus 13 is 33. So that's the other thing when you're doing math. I'll look at this and I'll take 18 plus 2 to make 20 and then add 13 to make 33. So, because 20 is easier to form. Because if you do the other way, you're like 13 plus 18, you're like, that's 21, or it says 20 plus 11, so that's 31 plus 2. That's just, it takes up too much space in my brain at least. So I would look and put 18 and 2 together to form 20 plus 13. So,
Or you could do 13 plus 2 is 15.
yeah,
15
then
plus
plus 18. Yeah, but then that's getting awkward because then you have to carry over the.
We get the 15 plus 15. It's
Yeah.
30 plus that last.
Oh, I
two.
see. Okay. You can do it
You
that way.
could.
You could, yeah. I like your thinking.
We like to be different.
Okay. So this is your chance though. Does anybody have any questions on how to do this stuff? It looked like when I went around, looked like people were following. So everyone's good? Okay. Because this is where you should make your mistakes, are in class. Don't fake it in class. You get individual attention. And this is when you'll learn. It's better to make your mistakes and be confused in class than when you get your test, and then you have that oh crap moment, right? Have your oh crap moment here right now. Or come talk to me after class. We have more oh crap moments. So, okay. This is where we got in the last class. And I'm inclined to stop now because I also want to go catch my plane in less than 2 hours. Does anybody have any questions? Okay, I'll stop here, and no one will know about it, especially since I'm putting the lecture on the internet. Question?
I had a question on the online.
Okay. Yes, what's the question?
I submitted something and I didn't entirely finish it.
Yeah.
And it just she didn't tell me that I didn't finish it. I just gave me a
Okay.
just,
Can you write me an email and I can give you the credit for it?
well, I didn't fill out the entire question. Like I don't
Okay. Does it?
You might be able to reopen it. I'm not sure.
I can only reset the entire assignment. So I can't do it on a problem basis. I have to do it by a chapter basis. But do you want to know the? I can give you the print view of the answers. You want that? So that we
Well, the thing is, I like to. So I finally got this one because, but there was that one that I didn't answer, and I think I submitted it and I just counted it as a 0.
Okay.
Alright.
What's part C? What are you asking? You want to? What are you asking for? You want to redo it? You want to?
Yeah, it was exercise. I think it was. This
I'll get you.
That's why I'm gonna go get beefy.
I'm
Yeah, I'm gonna get a little.
Oh wait, never mind.
It's crazy. I came home from China. I was like 30. I don't know. I lost about 30 pounds since then.
Oh no. Which
So
one?
bad.
Yeah.
Everything. Instead of just the Right, because I've been till 7 and I'm here anyways. Because I was
and then I fell forward.
Okay. Yeah, that's probably weird. What
My
color
whole,
is it?
it's like a grayish blue color, so it's like,
I know gray. I would, my dad would probably be a lot better if I took the time off my day.
Yeah, that's. Is it a second or third grade strike? Okay.
Not that.
it's fine.
Yeah, that's 4 to 6 weeks. That hurts.
Well, mail can.
I like instantly
Kind of like
elevated ice.
Yeah. Michael, I'll help you with it if you want.
No, never mind. I clicked on percentage and then it was like the numbers.
Okay.
Like the actual
Okay.
name of it.
Bye, travel safely.
So sorry about that.
Oh, no worries. Yeah, no, I sprained, that's your right foot. So I sprained my left, second degree sprain. Yeah.
I can't try.
Oh, yeah, I guess you're right.
I have to be.
Yeah, ATFL is anterior talifib. So your this bone. Oh, this is. Oh, I say fibia. This is your tibia, So, and your talus is in. It's like a bone in your ankle. So it's the talus and then the anterior on the outside going to your fibia. Yeah, yeah, that's the most common ankle sprain.
I emailed some Peter Fisher in my lab. I did this. I was like at the urgent care yesterday
Yeah.
morning when I was supposed to be in lab, and I emailed him. He doesn't emailed me back, but he emailed the whole class.
Oh, whoops.
So I don't know if you got it. I don't know where his office is.
You want me to show you where it is?
That would be great.
Okay.
Do you know if he's there?
No, but I can.
Please show me where his office
Yeah,
is.
it's right by mine.
Cool.
And I certainly know where my office is.
I would only hope so.
Oh, I should turn off the